Hey everyone, welcome to my channel. In this video we are going to learn how to perform facial recognition with high accuracy. We will first briefly go through the theory and then learn the basic implementation. Then we will create an attendance project that will use webcam to detect faces and then record the attendance live in an Excel sheet. I upload videos on a weekly basis, so don't forget to subscribe and give this video a thumbs up if you find it useful. So let's get started. So today we will be using a face recognition library to actually recognize our faces and differentiate between different people. Now, before we start with the implementation, let's have a brief look at how this library works. So here we have an article written by the author himself. His name is Adam, and we will have a quick look at it so that we can understand how the backend works. So there are a couple of steps required to perform this facial recognition. So the step one is actually finding the faces, and they are using the HOG method at the backend, which is histogram of oriented gradients. And once we have the this is a sample of HOG, and once we have the face, that is the bounding box where the face is present, then they apply a warp. Because for example, if you look at this is a frontal image, and if you look at this is a little bit tilted, and for the network to understand a human, this will be completely different than this. So what they do is they try to make all the images look something like this. So they use the dlib library at the backend. If you want to know more about dlib and how it works, I have a tutorial on that. You can check it out in the description. So what happens is that they find the facial landmarks, and using these landmarks they actually warp the image so that it looks more like this. So it is more centered. And once they have this image, they will send this to a neural network which is previously trained. And what that does is that gives us the encoded features. Now, what are these features? Now, as a human, this is a good example. As a human, if you think about this, it might be the measurement might be the difference between your eyes, the distance between your nose and the lips, the size of your lips. You know, these are the things that you might think of. But for a network, it automatically trains itself to find these best measurements. So that is what the network has done already. So what it does is, for us, we only feed in the image and it will generate 120 different measurements for us. So for example, for this image, you can see that this was the input image and it generated these 128 measurements. Now, using these 128 measurements, we can define a person. And using these measurements, we can differentiate between different people as well. So the last step is to differentiate them and to find the matches. So to do that, you can, as you can see, these are simple numbers. You can use any machine learning method. Over here they have used SVM classifier, the linear model of it, and using that they can differentiate between these measurements, and they can tell whether the measurements are of the given person or not. So that is the theory, the brief theory. And if you want to learn more about this, I will leave this link of this article in the description. Now, before we can use this library, we have to install the C compiler. Now, if you go to the Visual Studio website, in the download section, we can download the community version for this. Now, once we download that, we will have something like this in our installation. And what we have to do is we just have to select the desktop development with C++. So that is the only thing that is required. So once we install that, we can come back to our PyCharm project and we can install the dependencies. So let's go to File, Settings, and then we will go to the project interpreter and we will add the dependencies. Now the first one is CMake, so we will write CMake. We will install that. Then we have dlib. Now I actually face some issues with the dlib library, and I will not recommend using the latest one as it yields a lot of errors. So what I recommend is to use 19.18. So we can install that. Then we will install face recognition. Then NumPy, and the last one is OpenCV. So once they are done installing, we are going to import them. So the first one will be import CV2, and then import NumPy as np, and then we will import our face recognition library. So import face recognition. So we saw that there are a lot of steps that we have to perform to actually do the facial recognition at the backend. But because we are using this library, we just have to call a few functions to run it. Now what I have done is I have broken this down into 3 steps, and we are going to look at step by step how we can use this library. So the first step is basically loading the images and converting it into RGB, because we are getting the image as BGR, but the library understands it as RGB, so we have to convert it. Now if we look at our directory, we have images basic. Now we are running the script basics, so that's why we are using this one. What we have here is 2 images of Elon Musk and 1 image of Bill Gates. So if we open up, this is the image of Elon Musk, and then we also have a test image for Elon Musk, and then we also have a test image for Bill Gates. So what we will do is we will train we will get the encodings of our normal image, and then we are going to use the test image to see that if it can find the picture of Elon over here or not. So coming back to the steps, the first thing we will do is we will import our image. So we will write image Elon is equals to face recognition dot load image. So it gives us a function to load images, so that's why we are using this. So we have image basic, and then we have Elon Musk. So then we will convert this into RGB. So we will use cv2.cvt color, and then we will write image Elon, and we will write cv2.color BGR to RGB. Then we can write cv2.im show, and we will give it a name. So we will say Elon Musk, and then we will write image Elon, and we will write cv2.waitKey, and we will give a delay of 0. Similarly, we are going to import our test image. So we will copy this, and over here we will write image test. We'll copy this and paste it, and we will change this to Elon test. So then we can copy this again, and we can paste it here, and then we can write here test, and this one is test as well. So if we run this, and there we have our 2 images. So this is the test image, and this is the normal image that we will use for encoding. So this was step 1. Now the step 2 is finding the